Hello, Enmadeo. My name is Hannah Cheska Villarosa, a first-year student from College of Engineering Education. And for today's video, we're going to talk about an important and interesting topic in mathematics. Are you ready? Come on, let's dig in. So, as you can see, there is a five pictures in front of you. And do you observe something about these pictures? Are they related? Do they connect to each other? Let's find out. Yes, you guessed it right. For today's video, we're going to talk about apportionment, specifically the Jefferson's plan. Maybe the word apportionment is something new to you. So what is the meaning of apportionment? So apportionment is a crucial process in representative democracy that ensures fair representation of different regions or groups within a larger entity such as country. One of its prominent example was here in the Philippines. Did you know that we have House of Representatives? So here in the Philippines, we have 253 House of Representatives, which represents per districts here in the Philippines. So the Jefferson Plan is one of the methods used to achieve this equitable distribution. So because Philippines is a democratic country, so those House of Representatives is being chosen by the use of this method, the Jefferson Plan. So, what about in the context of mathematics? So, apportionment is a mathematical process used to allocate seats or resources among different recipients based on some set of criteria. So, in political context, it often refers to how seats in a legislature are distributed among various constituencies based on its population. How about the Jefferson Plan in mathematical context? So Jefferson Plan is also known as the method of greatest divisor, is a specific apportionment method named after Thomas Jefferson, the person who I showed to you earlier. So Thomas Jefferson who proposed it in 1790. So this method is primarily used for dividing a fixed number of seats among states and regions based on their population. So, throughout this topic today, here are the definition of terms that we're going to encounter throughout this video. So, to lessen your confusion about it, so let us first define what are these terms means. So, first is the population. So, population is the total number of individuals residing to a specific area, often used as the basis for representation or resources allocation in governments. So next is the quotient. So based on the governance. So for example, here in the Philippines, we have approximately 100,000 people. So that is the population goes in. So next is the quotient. So quotient is the result obtained when dividing one quantity by another, frequently used in apportionment to determine the number of representatives per population unit. So the next is the standard quota. So standard quota is a calculated figure representing the ideal number of seats or representative a given population should receive, derived from dividing the population by a predetermined divisor. So next is the modified quotient. So modified quotient is an adjusted figure used in apportionment that typically accounts for certain constraints or desired outcome by modifying the standard quota through a specific algorithm of formula. So next is the number of members. So number of members is the total count of representatives or officials allotted to a specific entity of governing body within an apportionment framework. So it is also called a number of representatives. So NOR stands for number of representatives is the term that we are going to use later. So next is the seat. So, seats is the designated position or places in a legislative or governing body that are filled by elected or appointed official determined through apportionment process. After knowing those definitions, let's move forward to the formulas that we're going to use throughout this Jefferson's plan. So first is the standard divisor, which is denoted by SD, or SD equals total population over number of seats. Then the next formula that we're going to use is the standard quota, which is denoted by SQ, or SQ equal state population over standard divisor. Before we dig into the actual problem solving, let us know first what are the following steps that we are going to use in order for us to apply Jefferson's plan in word problem. So first step is the initial setup. So initial setup is used to determine the total number of seats. For example, in legislature, so that needed to be apportioned and the population of each group, state, or region. So the next step is the divisor selection. So start with a divisor that is equal to the largest population. The initial divisor is often set to the highest possible number, such as the population of the most populous group or number that help ensure that the total number of seats allocated does not exceed in the total available. So the next step is to calculate the quotient. For each group, calculate the quotient by dividing the population of the group by its divisor. So this quotient indicates how many seats a group would receive with the current divisor. So in this part, we're gonna use the SQ formula or the standard quotient formula. The fourth step is to allocate seats. So what does that mean? Allocate seats based on the interior part, the whole numbers of the quotient calculated. If the group receive a whole number of seats, that number is assigned. So the next is to adjust the divisor. So if the total number of seats allocated does not equal to the number of available seats, adjust the divisor downward, reduce it slightly, and repeat the step 3 to 5 until the total number of seats allocated matches the total available. So the final step is the final distribution. So once the appropriate divisor is found, the final distribution of seats is determined by the interior part of the quotient calculated with the divisor. So let's try our word problem number 1. So for our word problem number 1, let's go. A sari store has 30 customers. So 30 customers is the total population. And the store owner wants to form committees for different departments, such as clothing, accessories, household items, and snack. Each committee will have 3 members. So the total number of customers interested in each department is as follows. So first is the clothing. In clothing, we have 9 customers. In accessories, we have 7 customers. In household items, we have 5 customers. And snacks, we have 9 customers. Using the Jefferson plan, determine the exact numbers of committee members for each department. So let's solve problem number 1. So in order for us to solve for our problem number 1, let us write first the given. So we have our total population, which is 30. And our seats, or the seat that need to be allocated, is that. So let us write the table for us to organize the given information. So this is the table. Yeah. This will be the departments. So we have clothing, accessories, um, household items, and snack. So in this part, this will be our state population. So how many customers are there in clothing? So we have 9 customers. In the accessories, we have 7. In the household items, we have 5. And in the snack, we have 4. Let's add together. 9 plus 7 is equals to 9. So, okay. And in the snack, we have 9. So let's add together. 9 plus 9, 18 plus 7, 18 plus 7, 25 plus 1. So we have 9. Let's add together, which will give us 30. So as you can see, they're equal to the total population. So after identifying all of the given information, let us solve first our standard divisor. So this is our formula. So the standard divisor is equal to total population over the allocated seats, which is 10. So 30 divided by 10, which will give us 3. So this is our standard divisor. So the next thing that we need to do is to divide our standard divisor to respective state population. So this is our standard quotient formula, which standard population over standard divisor. So this will be our quotient, and this will be our standard quotient. So 9 divided by 3, which will give us 3. 7 divided by 3, which will give us 2.33. 5 divided by 3 will give us 1.66. Lastly, 9 divided by 3, which also gives us 3. So, ang kukunin lang natin dito sa ating, ang ilalagay lang natin dito sa ating standard quotient is yung whole number. So, this will give 3, this will be 2, 1, tsaka 3. So, i-add lang natin. So, 3 plus 2 plus 1 plus 3 will give us 9. So, 9, as you can observe, 9 is not equal to 10. So, in doing Jefferson's plan, let us adjust our standard divisor, which is ang standard divisor natin is 3. So, ang gagawin lang natin, maghanap lang tayo ng value na less than 3. So, try natin yung 2.5. So, this is our initial standard divisor, and this is our modified standard divisor, which is 2.5. So, ulitin lang natin yung step dito. So, ulitin natin siya pag divide sa 2.5. So, this is our modified quotient. And this is our number of representative, which is yung final na. So, erase lang natin to. So, 9 divided by 2.5 will give us 3.6. This is our modified quotient. So 7 divided by 2.5 will give us 2.8. 5 divided by 2.5 will give us 2. And lastly, 9 divided by 2.5 will also give us 3.6. So, ulitin natin yung step. Kunin natin yung whole number, which is 3. Dito naman, we have 2. 2 at saka 3. So, i-add lang natin 3 plus 2 plus 2 plus 3 will give us 10, which is equal sa 10 na kailangan natin i-apportion. These are the final list of number of representative. Do you find it easy? Now, let us solve our problem number 2. So you are planning a group trip with 60 people. So 60 people is our total population. And you need to form committees for different aspects of trip, which has budget, itinerary, accommodation, and transportation. So each committee will have 12 members. So the number of people interested in each aspect is as follows. So in budget, we have 20 people. In itinerary, we have 13 people. In accommodation, we have 15. And in transportation, we have 12 people. So using the Jefferson plan, determine the exact number of committee members for each aspect. So let us solve number 2. So let us proceed to our problem number 2. So first step is we need to identify the givens. So we have our total population, which is 60, and the seat that need to be apportioned is 12. So these are the aspects. So we have budget. We also have items and accommodation. And lastly, we have transportation. So in budget, we have 20. In items, we have 13. In accommodation, we have 15. And transportation, we have 12. So the first step that after identifying all of the givens, so let us solve our standard divisor. So our total population is 16 and the seats is 12. So 60 divided by 12 will give us 5. So after getting our standard divisor, let us divide our standard divisor to the respective state population. So 5 will give us 4. 13 divided by 5 will give us 2.6. 15 divided by 5 will give us 3. And 12 divided by 5 will give us 2.4. So let us get our full number, which will be 4. Here we have 2, 3, and 2. So let us sum up together. So 4 plus 6 plus 3, 9, 10, 11. As you observe, it's not equal to the total seats, which is 12. So going back, which is 5 to lesser value, which, so let us try 4.5. This is our modified standard divisor. So let us repeat our step. So let's erase this 5 to 4.5. So 20 divided by 4.5 will give us 4.65. So 13 divided by 4.5 will give us 3.02. So 15 divided by 4.5 will give us 3.48. And lastly, 12 divided by 4.5 will give us 2.79. So let us get our number of representative, which is the whole number. So we have 4, we have 3, we also have 3 and 2. So let us sum up together, will give us, for the C, 12, which is equal to the number of seats to be apportioned. This is the final list of the committees which is needed for every aspect. So in budget we have four, in items we have three, and accommodation we have three, and the transportation we have two. I think number two is just too easy for you. So let us move forward to problem number three. So Mid classroom has 30 students, and she wants to form committees to represent different subjects. The subjects are mathematics, science, English, history, and physical education. So each committee will have five members. The number of students interested in each subject is as follows. The student who is interested in mathematics is 8 students. In English, we have 5 students. History, we have only one. And physical education, we have 10 students. So using the Jefferson's plan, determine the exact number of committee members in each subject. So let's solve problem number 3. Let us solve our problem number 3. So let us identify our given. So for our total population, we have 30 students. And the seat that need to be apportioned will be 5. So after that, let us identify these are the subjects. So we have mathematics, science, English, PE, history, and PE. So our state population for mathematics, we have 8. For science, we have 6. For English, we have 5. History is 1. And PES is 10. So let's sum up together. So 11, 16, 22, 38. So this will give us 30 students. So let us identify our standard divisor. So 30 divided by 6, which will be 5, will give us 6. So this will be our standard divisor. So after that, let us divide our standard divisor to the respective number of state population. So we have 8 divided by 6 will give us a quotient of 1.3. So 6 divided by 6 will give us 1. 5 divided by 6 will give us 0.8. 1 divided by 6 will give us 0.6. And lastly, 10 divided by 6 will give us 1.16. So let us repeat our steps. So let us find the whole number. So our standard quotient will be 1. So it will also be 1, 0, 0, and 1. So let's add together. This will give us 3. So you've noticed again, 3 is not equal to 5. So in order for us to get the right value of our standard divisor, so in order for us to get the proper value of our standard divisors, number is less than 6. So we can use 5. Let us try it. So let us raise it. So our modified standard divisor is 5. Then let us divide it respective state population. So 8 divided by 5 will give us 1.6. This is our modified quotient. So 6 divided by 5 will give us 1.2. So 5 divided by 5 will give us 1. 1 divided by 5 will give us 0.2. And lastly, 10 divided by 5 will give us 2. So let us Let us get our number of representative. So we have 1. We also have 1, ay 0 pala to. 0. So we have 1, 1, 0. This is 0 and this is 2. So let's sum up together. This will give us 5, which is equal to the seed. So these are the final list numbers of committee needed for each subject. Problem number 3 is just too basic for you. So let's go to our problem number 4, which deals a real life scenario of how apportionment works. The city of Metropolis has a total population of 100,000 people. The city council is composed of 50 representatives who are to be apportioned among the 5 legislative districts based on population. Each district has submitted their population counts as follows. So in District 1, we have 25,000 people. In District 2, we have 20,000 people. In District 3, we have 15,000 people. In District 4, we have 18,000 people. In District 5, we have 22,000 people. So using the Jefferson plan, determine the exact number of representatives for each district. So let us solve problem number 4. Let us proceed to our problem number 4. So in this case, things are more complicated. So let us identify our given. So our total population in the city of Metropolis, we have 100,000 people. And the number of seats is 8. So this will be our districts. District. So in our district 1, state population of district 1 is 25,000. In district 2, we have 20,000. In district 3, we have 15,000. In district 4, we have 18,000. And district 5, we have 22,000. So let us get first our standard divisor. So after knowing all of the given, let us solve now our standard divisor. So total population of number of seats. So we have 100,000 divided by 50. So 100,000 divided by 50 will give us 2,000. So this is our standard divisor. So after getting our standard divisor, let us divide it to the respective state population. So 25,000 divided by 2,000 will give us a quotient of 12.5. Next, 20,000 divided by 2,000 will give us 10. Next, 50,000 divided by 2,000 will give us 7.5. 80,000 divided by 2,000 will give us 9.0. Lastly, 22,000 divided by 2,000 will give us 11. So let us get its whole number for us to get our standard quotient. This will be 12. This will give us 10, 7, 9, and 11. Let us add up together. This will give us 49, which is not equal to 50. So in order for us to get the right value of our number of representative, let us get our modified divisor, which is lesser than 2,000. So let us find a number that is lesser than 2,000. So let us use 1,900. So let us try. So 25,000 divided by 1,900 will give us 13.6. This is our modified quotient. So 20,000 divided by 1,900 will give us 10.53. 15,000 divided by 1,900 will give us 7.89. 18,000 divided by 1,900 will give us 9.47. And lastly, 22,000 divided by 1,900 will give us 11.7. So let us get its whole numbers. So we have 15, 10, 7, 9, and 11. Let's add up together. So this will give us 50, which is equal to 50. So these are the exact number of representative per district. I think that was quite challenging for you. But now let us move forward to the most challenging problem in apportionment. So this is our problem number 5. So in the country of the motion, so this is just fictional country. This is not true at all. So there are 3 regions: the alpha, the beta, and the gamma. So the total population of the motion is 1,200,000 people, and the government has agreed to allocate 3 states in the National Assembly based on population. The population of each region are as follows. In region Alpha, we have 600,000 people. In region Beta, we have 400,000 people. And the region Gamma, we have 200,000 people. So, using the Jefferson plan, determine the exact number of apportionment of seats for each region. So, let us solve problem number 5. Are you still there? So, let us solve our last and final problem. So let us identify our given. So for our population, we have 1,200,000. So it's such a great value. So our seats will be 3. So for our region, we have alpha, beta, and gamma. So for each district, we have 600,000 population. For alpha, for beta, we have 400,000. For gamma, we have 200. So this, when we sum up everything, this will have 1,200,000 people. So let us get first our standard divisor. So 1,200,000 divided by 3, and 200,000 divided by 3 will give us 400,000. So is what our standard quotient formula. So let us divide our standard divisor to each respective state population. So 600,000 divided by 400,000 will give us 1.5. 400,000 divided by 400,000 will give us 1. And 200,000 divided by 400,000 will give us 0.5. So let us get our standard quotient. This will be 1. This will also be 1. This is 0. When you add up, this will only give us 2. So which is not equal to 3. So let us get our modified standard divisor. So let us just find a number that is lesser than 400,000. So in this problem, which is lesser than 400,000. So in this problem, we can use 300,000, which is more lesser than 400,000. So let us try. 600,000 divided by 300,000 will give us 2. 400,000 is divided by 300,000 will give us 1.33. 200,000 divided by 300,000 will give us 0.66. So for our number of representative, we have, let us get whole number. We have 2, we also have 1, and 0. We sum up everything. This will give us 3, which is equal to 3. So these are the final list of representative per the per region. So do you find it easy? I wish you say yes. But for now, this is our conclusion. In conclusion, the Jefferson plan is a significant method of apportionment that aims to balance representation by considering both population and land area. So, through these examples, we can see how the Jefferson plan can lead to more equitable representation, ensuring that all regions have a fair voice in legislative decision, and understanding the apportionment is important is crucial in maintaining a just and representative democracy. That's why we can say that Jefferson's plans is important here in the Philippines, as the Philippines is a democratic country. So before I forgot, these are the references that I use. If you have some questions, some inquiries, just go to these references so that this will give you a more clearer and more understanding about our topic. God bless everyone. Thank you and goodbye.